Right, morning class. I'm Reese, and today we're going to be looking at an interesting puzzle, or riddle you may call it. So, it goes like this. Okay, there are entitled people. Someone said this, some smart person said this. Okay, this is a famous code. Okay, today we try to demystify this. We try to understand what this means. Okay, so this is the number 10, right? So I'm gonna go ahead. This is very simple. Oh, what is this? This is 123. Okay. Now, could someone tell me why do we say this is 123?
Because we use base 10.
Yeah, exactly. So now, what is base 10? This we would have done this in elementary school, I think. This is called the units place. This is the tens place. This is the hundreds place. So how we express this is 3 times 1 plus 2 times 10 plus 1 times 100. Okay. Now, if you look at this, this is basically 10 power 0, 10 power 1, and 10 squared. Okay. So 10 forms the base of all we do here. So this is base 10. Now, can somebody tell me why was 10 chosen? Why couldn't be anything else? Why did we choose 10? It's a piece of common. Like, look at us. I'm doing it good. Yeah. Yeah. so we have 10 fingers and 10 toes. Hopefully I had a friend in high school who had a 6th finger here, okay? Okay. Some people thought it was cool, but thankfully he wasn't the one who designed this, okay? Otherwise we'd be doing this, alright? We're going to be doing 3 times 1 plus 2 times 11 plus 1 times 11 squared. Go figure. Okay, this would make math even worse than it is actually now, okay? So, coming to binary, so now, if I ask you, okay, how much light is in this room, would you even answer that question? No? Why? Because nobody really cares if there is light in this room. How much there is. As long as we have light in this room, it's okay. We have light or we do not. Okay? Now that is 2 states, light or darkness. We do not bother the exact quantity. Okay? So, most things in nature, they turn out to be binary. Like, am I dead or am I alive? Is this class boring or is it interesting? Okay? So there's a duality in nature. So, let's say good and bad, yes or no, true or false. So how people have represented this is basically 1. 1 typically stands for good things, yes, true, and 0 stands for false, no, those kind of things. Okay, so this is all we need in the binary system, since we treat everything as expressed as 2 things, so 0 or 1. So this is the total number of symbols we need in a binary system, no more symbols, So this is could somebody tell me what is a big advantage of the system? What do you think binary gives us? The biggest takeaway. It is that we have only 2 symbols. Okay? So say we live in a world where we use binary, we'll be teaching our children just 0 and 1. We will be teaching them 0, 1, 2, 3 and all till 9. Okay? Now how does this help? Computers run on binary. Computers, as it turns out, aren't very smart. Okay? Okay, so we need to be able to teach them. And turns out teaching them just 2 symbols is easier than teaching them, say, 0 to 9. Okay? So, and let me tell you how a computer answers a question using this. Okay? Yeah. Okay. Can I have your name?
Jake.
Okay. Can you tell me his name?
Jake.
Okay. What a computer would do is, after hearing his name, if I ask the computer what his name is, it will search through a list of people's names. They ask, is his name A, is his name B, is his name C, and so on. So it comes to J, the computer is going to say, yes, it is J, and it's going to put it on the screen, you know what, he's J. Now we're going to think, wow, the computer is really smart. It looked at this picture and said it's J. But what it's actually doing here is going through a billion other people's names and telling it's J. It's actually very dumb. But then what computers do is they're very fast, which we are not. It can do like billion times faster than what we do. So within a matter of microseconds, it gives us the result. So we are amazed. Okay? So this is how binary helps us in computers. So let me extend this. Okay? Now, if I had this, I'm telling you this is the base 2, that is binary. Could someone extend this? What I've done here? Could someone tell me? Like what I've done is, I've used base 10 here, base 11 here. Okay? How would that be for base 2? Anyone choose? Instead of 10 here, I just need to replace this by 2. Okay? So it's going to be 0 times 2 power 0, 1 times 2 power 1, and 1 times 2 power 2. Okay, that works out to be 6. Okay, that's 6. Now, if you could just work this out, what would this be?
What does the subscript do?
It says it's binary.
Oh, okay.
12.
Same.
Oh, wait, hold on, 12.
Yeah.
Alright.
Yeah, that's 12. Okay. That is 12. Okay. Same thing. 0 times 2, 0 times 2 power 0, plus 0 times 2 power 1, 1 times 2 square, and 1 times 2 cube. That's going to give you a 12. Now, let me tell you something interesting. Skip binary, decimal. Okay. This is 23. If I ask you to multiply this by 10, you'll be getting me 230. Just add a 0. Okay. Look what I did here. It's 6 times 2, 12, and I just added a 0. Okay, because this is base 10, multiplying by 10 equals putting a 0 at the end. Okay. Same way, base 2, multiplying by 2 means putting a 0 at the end. Okay. So I would encourage you to find more similarities between binary and decimal. Okay. And today, look at this. This is how we started. Okay. 10 in binary, what does that mean? 0 times 2 power 0, 1 times 2 power 1. Okay, this works out to be 2. So there are 2 types of people in this world who understand binary, who don't. That's how this riddle is solved. Okay? I hope you like this. We'll see more about binary in the next class.